In this video, I'm going to go over finding the domain of a composite function. Now, first step is we need to find the domain of the individual functions themselves. You'll see why when we get to the next step. All right, so what is the domain of f of x? Well, it has a denominator, right, because there's a fraction there. And the denominator cannot equal 0, right? So x minus 1, which is the denominator, cannot be 0. Okay, so we add 1 to both sides. So x cannot be positive 1. That is for f of x. Okay. Store that for later. Let's just write it up here. X cannot be positive 1. It's a bit of a wavy 1, but whatever. Okay, same deal here with g of x, right? This denominator cannot be 0. When all is said and done, or we're going to have an undefined function, right? So let's isolate the x. That's cannot equal. X cannot equal 2/3. Okay. Cannot equal 2/3. All right, with me so far? Now that we have that, now we can try and find the domain of this, right? Because if x cannot equal 1 here, then x could equal anything but 1. And if it can't be 2/3 there, then it could be anything but 2/3. But this is a little different, though, because first we do g of x, and then we put the output of g of x into f of x as the input, right? So what if the output is positive 1? Then it will be undefined, and the whole composite function is undefined, even though the number falls within the domain or the range of g of x, right? So our entire output cannot be 1. So that's where this comes in, and we take all of g of x, 4 over 3x minus 2, and we say it cannot be equal to 1. And we find out what value of x gives us a 1 for an output, right? We're not just doing the denominator this time, we're doing the whole thing, okay? So first thing we do is we multiply, let's make the bigger parentheses here. That looks awful. Let me just start over. 4 over 3x minus 2 cannot equal 1. So in order to get rid, to isolate the x, we need to kind of get rid of the denominator here, okay? So we just kind of multiply both sides by 3x minus 2, okay? And that cancels it out, so we're just left with 4 on this side, and 3x minus 2 times 1 is just 3x minus 2. Well, that was easy, right? Add 2 to both sides. So x cannot equal 2. So 6 divided by 3 is 2, right? So, because it's f of g of x, our domain includes the domain of g of x and whatever output gives us 1, which is 2. So we cannot include 2 or 2/3. But we can include 1. If we put in a 1 there, 1 times 3 is 3 minus 2 is 1. Okay, that's 4. See, 4 as our output, that's not 1, right? So 1 is okay for this composite function, not for f of x, but it is okay for this composite function. Does that make sense? So we're including this in our domain, or this rule, that we cannot include 2/3, and we cannot include 2 in our domain. So start with negative infinity, right? We can include everything, yeah. All the way up to, what's the smaller number? 2/3. All right. Parentheses, not including the 2/3, in union with everything to the other side of 2/3, all the way up to positive 2, in union with what? Just going to skip over the 2 again, and then go all the way to infinity, including everything else. So there is the domain of the composite function f of g of x in interval notation. We're including everything but 2/3 and 2. Does that make sense? Because we're not plugging x into f of x, we're plugging it into g of x, and that output is being plugged into f of x. All right, let's do part B now. Now I wrote this in a slightly different format, but it means the same thing as f of h of x. Little extra parentheses in there. All right, it means the same thing, f of h of x. That's just a different way of writing it, okay? So what do we do now? Well, we haven't found the domain of h of x yet, so let's do that. What's the rule for radicals? Well, what's underneath the radical can't be negative, right? Because then that would be imaginary or complex. So what's underneath the radical has to be greater than 0. Right? Greater than or equal to 0? Yeah, I suppose it could be 0. Yeah. Greater than or equal to 0. X is greater than or equal to -4. So, note that up here so we don't forget. All right. Now what? Well, the output cannot be +1 still, right? So we need to set this whole thing equal to +1, because we know that our output this time cannot be 1, because h of x is being, the output of h of x is being used as the input for f of x, and the input for f of x cannot be 1, right? So we need to find what value gives us the output of 1 in h of x. So first thing we do is we get rid of the radical by squaring it, right? Square both sides. And then we subtract 4. X cannot equal -3. Okay. Now what? So now we just write out the domain in interval notation, right? We have both restrictions Is negative 3 greater than or equal to negative 4? Yes, it is. So you got to remember, we don't start with negative infinity this time. We start with negative 4, and we include it. So we put a bracket, comma, we go all the way up to negative 3. Such a big jump. And then we do not include negative 3. And then we jump to the other side of negative 3. And then we keep going on forever. So bracket, parenthesis, parenthesis, parenthesis. And there's our domain of f of h of x. All right, this is grand finale, part C. We're just going to flip this over, kind of do the opposite composite function of what we just did. Instead of f of h of x, we're doing h of f of x. Let me show you the difference here. Since f of x is what we're starting with, then we need to make sure that the output of f of x is not less than negative 4, right? So the output of 5 over x minus 1 needs to be greater than or equal to negative 4. Because remember, the domain of this is everything but positive 1. So it would be all those negative infinity numbers and all those positive infinity numbers. So there's a bunch of numbers that we're going to need to eliminate from that domain before we can have our full domain here. So what do? Multiply both sides by that denominator to get rid of it, right? It's not negative, so we don't need to flip the sign. It's always good to mark that in your mind. Okay, negative 4 times x minus 1. Remember to distribute. Negative 4x plus positive 4, right? Negative 4 times negative 1 is positive 4. Okay, now what? Subtract by 4. 1 is less than or equal to negative 4x. Divide by negative 4. All right, this is when we flip the sign, right? You got to remember, if we are dividing or multiplying both sides of an inequality by a negative, we got to flip that sign. So this becomes less than or equal to, and this is just negative 1/4. Okay, so we combine this restriction with this restriction, and we get the domain of h of f of x. All right? So let me write this from left to right. X is greater than or equal to negative 1/4. Right? Yes. So on the far left, the lowest number that we could possibly start with is negative 1/4. And we go up to positive 1. And we do not include it. We jump over it in union with everything to the right of positive 1. And there's the domain of part C, h of f of x. Thank you for watching.